Hey everybody. So I wanted to do a quick video showing you one of my projects. This is supposed to be a robot RC car thing. It's supposed to drive around by itself and not run into stuff. I'm still working on the not running into stuff part. And so let me show you what we got on here. So on the front here we got a ultrasonic distance sensor. I have an H-bridge motor driver set up here, Arduino Uno clone, and then on the back here I have an on and off switch. Then I use a 2-cell 1000 milliamp hour battery, LiPo battery, that goes in the back here. And then I just plug this in here. And then when I flip the switch on the back, so it still has some bugs in the code. I gotta change some stuff with the distance sensing and some other stuff. So let me show you the code, and then I'll put it on the floor and show you what it's doing. Alrighty, so here is the code for the RC robot car. So here in the beginning we define the pins for the H-bridge motor controller, and then we include the new ping library and define the pins for that and the max distance. Then we have some stuff set up here for timers. The new ping sonar, you got to set the pins so the library knows which pins do which function. And then I have some stuff set up here for a randomization, which I'll explain here in a few seconds. And then under the void setup, we set the pin modes and start serial communication. Then under the void loop here, some more setup for timers, and then we check the distance with sonar.ping. Now this is where I set up the randomization. So if you remember up here, we got R1 equals 0 and R2 which equals 500, and we got ran turn which equals 0. So what we do is, if random direction, which is the same as mils, minus R1 is greater than R2, so if this number becomes greater than 500, and ran turn is equal to 0, which it will be the first time it goes through, then it's going to set ran turn to 1. The second time it goes through and it reaches 500 milliseconds, this statement will no longer be true because this is no longer 0. It is now a 1. So we go to this one here, this else if statement, and basically do the same thing, only we set ran turn back to 0. Now you may be saying, well, why would I want to do that? Well, let's continue here. So then we come to here, if the distance is greater than or equal to 3000, continue going forward. Else, now this is where that ran turn comes into play. Else, if the distance is less than 3000 and ran turn is equal to 0, then we're going to do this setup here, which makes it turn left. It backs up and turns left. Then it checks the distance to see if there's anything in its path. If there is, it's going to turn left again. And it's going to check again. If there's anything else, it's going to turn left again. Hopefully by that time, it should be able to go forward again. But if ran turn is not equal to 0 and the distance is less than 3,000, then we're going to go to this statement here where we do the same thing, only we turn right instead of left. Then after all that, we print the distance to the serial monitor and then go back to the beginning of the loop. Now, to get the forward functions and the stay functions and the backwards and all these, I had to set up some other stuff. So let's look at this. So we have void RM, which is right motor, and we have void LM, which is left motor. And what I'm doing here is I'm setting up some cases that I can call for stop, forward, and backwards for each of these motors. And then I do some stuff here to set up the speed so I can control the speed of each motor. So once we've done that, then we can go down here and set up what we want to set up our forward and backwards parts for the robot. So under void forward, we set both right motor and left motor to 1. And for the backwards, we set it to 2. And left, you just do left and right, you just set which motor needs to go forward and which one needs to go backwards to turn it in the correct direction. And then void stay just stops the robot. So that's basically how it works. I'm not very good at explaining it, but if you guys want to look at the code, I will have a link to it in the description down below. You guys can edit it. If you want to make changes and maybe send it back to me and say, hey, this might work better, go right ahead. I'll try them out. But alright, now let's go and see what it does on the floor. Alright guys, so I'm on the kitchen floor here and we're going to turn it on and show you what it does. Here we go. So what's happening here is it's sensing something in front of it and it doesn't know what's behind it. So it just ends up running into stuff when it goes backwards.